3. Good morning, everybody. Welcome back to lecture number 10. So let me begin with an imagination. Let's say I have a big circuits, resistors, motors, batteries, current sources, and it's a spaghetti, okay? How can I, in two terminals of the system, A and B, replace it with a simple resistor and a simple voltage source to mimic the same A and B? In other words, can I have a box that mimics this behavior? If we have this, then yeah, that's called Thevenin equivalent. If I replace it with a parallel resistor and a current source, can I have another representation? That's called Norton. Okay? So we have Thevenin related with voltage source in series with the resistor. Norton, it's a current source in parallel with the resistor. Now, question number 1 in the major exam, maybe, not sure. And it was remember exercise 0.0? What is the voltage drop across this circuit? Anybody who doesn't remember this exercise? Okay. Why we said 5? Because the current is?
Yes.
Okay. What is the voltage drop What is the voltage drop across the terminals of this box? Well, what should we do? This 1 amp will go here, right?
Yes.
Will it go there?
No.
Because it's a hanging cable on the air. معلق في الهواء. With plus minus to avoid the passive sign configuration. Then VAB equals, what's the formula? Plus 1 amp times 5, which is 5 volts. So we can have the same voltage drop, right?
Yes.
Assuming this is an open. Now, if we connect it to systems, it's not gonna be. It's gonna be different.
Will it be 0, Victor?
Hmm?
Will it be 0?
0 1. Now, which one?
If we connect.
If we connect short circuit, chip حريقة.
If it's ideal circuit.
Well, whatever resistors here, it will be combination of 5. That's what I'm saying. Key here is, you're measuring 5 volts here, 5 volts there. So today we'll talk about Thevenin equivalent circuit, Norton equivalent circuit, source transformation. A, B, and C, it's the same thing. Hopefully we have some time to finish maximum power transfer. So this is the spaghetti circuit. The spaghetti circuit, we can replace it with simple VT or TH, let's call it TH, Thevenin, in series with R Thevenin. Okay? So this is an independent voltage source in series with the resistance. How to find those elements? We have 2 processes. What I tell the students, you can start with 2 and then 1, because 2 is very easy to find. 1 requires work. So find R Thevenin of that spaghetti, okay, of that spaghetti, we find R Thevenin by killing the sources. So if we have a voltage source, we replace it with, how to kill a voltage source? To kill it, replace it with a cable. How to kill a current source? Replace it with an open cable. Basically, you erase it from the board, the voltage source, you draw a line, and that's it. so that you save 2 minutes in the test. I'm going to show you examples. Let's do this example, okay? Again. Now we are professionals, right? Is this circuit marked?
No.
So a professional, what a professional should do?
Put the sides.
You should draw on your maps, right? Let's do it. 15 volts. R1, R2. This is what? 50 ohm. This is 100 ohm. And this is the terminals with white dots means. What did we say white dots mean?
Open circuit.
No, not open circuit. Yeah, it's open circuit, but it's connectable. We can connect it to whatever system B. Okay? In Thevenin and Norton, you're always looking this way. You're always looking this way. You're always looking this way. Okay? So where is Thevenin? This is Thevenin, okay? So he's looking that way, okay? Okay? So Thevenin is asked to find the R Thevenin, okay? What did I say? I say every voltage source should be replaced with a short circuit. Get it?
Yes.
You draw a cable. Now, what is R Thevenin? It's nothing but R1 in parallel with R2. Now, 100 inverse plus 50 inverse, all inverse. What's the answer? 20, 33? Whatever. You want me to do the math? Can we have a volunteer to work on my calculator? Where is your calculator? Who doesn't have a calculator? Raise your hand. You don't have a calculator? Okay.
33.7.
Okay, that's how it should be. In the test, I can tell you, if you do everything by calculator, you can solve the MCQs very fast. That's why I'm asking you to do it in class. And in the help session. Don't forget your calculators. Okay. So R Thevenin is 33.3. How to find V Thevenin? Well, you go back to the original circuit and you try to find R1, R2, original circuit. 50 and 100. How to find V open circuit? Is it worth doing node voltage analysis? Is it worth doing mesh analysis? Do you guys remember voltage divider rule? So we use VDR. Why? Because these are in series, right? This is nothing. This is hanging cables. Hanging cables. Don't care about them. So using VDR, voltage divider rule. So what is VOC? So why we call it OC, open circuit? We are opening this circuit. It means we're testing the box. We're testing the spaghetti, okay? Open box, open circuit. We're testing the circuit. So V open circuit is where Thevenin is looking. Thevenin is a guy. Norton is another guy, okay? We key them. Let's continue. So V Thevenin, V open circuit is what? VDR. Who wanna do the VDR quickly? Rahman.
Current 50
Numbers quickly. 50 over
50 over 100 plus 50.
times, and then this is 5 volts. A smart student would say a third of the voltages would appear here, another 2/3 would appear there. So we can replace it with 5 and 3.3. Okay? I'm not gonna do mesh because it's waste of time, but you can use VDR, which is 15 over R1 plus R2. You calculate I1, then you do I1 times R2. This is for the kids now, right? Is it a kid problem?
Yeah.
This is now a kid problem. I'm not gonna solve it. This is using KVL. Okay? Mesh doesn't have, mesh is very, like, mesh, you need multiple loops. Node voltage analysis, you need multiple nodes. That's a good judgment test. Okay, let's do another example. This was an easy example. Let's do a harder example. So in the test, if you see a current source and voltage source, read the question. Okay? We read this question. Okay, we are professionals now, right? So we have plus or minus 20, 5 ohm, 20 ohms, and then we have a current source of 2 amps, right? What did I tell you about Thevenin? Thevenin is very smart. He doesn't have time in the test. He would rather find our Thevenin before Thevenin. So what he does, he would kill the sources. How would he kill the current source? No, let's kill the current source. Open means erase it without doing anything. Erase it. In the test, you can bring an eraser and erase it. You can scratch it, but if you scratch it, it will make a mess. How about the voltage source? Short circuit. And our Thevenin will look this way, huh? So what he's seeing is 20 in parallel with 5, right?
Yes.
So what is 20 inverse plus 5 inverse all inverse? 4.
4.
Get it? This is easy in the test. Thevenin would now do the harder task, which is finding V open circuit. He would put back the current source. He would put back the voltage source. And he would look that way. Thevenin is very smart. He would say, if I do KVL and KCL, it will be a mess. If I do mesh, I don't have time. Thevenin tend to prefer, because he is trying to find V Thevenin, he would love to use node voltage analysis. Because ultimately, node voltage will give you voltages. Current, mesh analysis ultimately will give you what? So now, Thevenin is going through chapter 1. He would say chapter 1 is, take lots of time, I don't have time in the test. Thevenin would do node voltage analysis. How many nodes in that circuit?
3.
Why 3? 1, 2, 3. Are those 3 nodes?
No.
1, 2, 3. Okay, we want professionals. Who are the professionals who would name the nodes for us?
Resistor after the resistor and the...
Okay, so we have one node here.
Yes.
That's one. What's the other? And I know it's voltage. Which is what? 15? 20. What's the current? No. How many nodes? The ground, node number 2. And then we only have one big node here, sir. All of this is a node. So that's the node of interest. We call it VOC, open circuit node. Get it? Get it? So whoever said 3 nodes, assuming the ground, you're right. If you say 3 nodes, not including the ground, come and see me in the office. Unless you got it now, okay? Let's do the fake currents. We have here IA. We have here IB. We have here IC. Do you have a current here? BI? Because it's an open circuit, or we call it hanging table. So IA plus IB plus IC equals 0, right? What is IA? VOC minus 20 over 5. Clear? What is VB? IB? VOC minus 0 over 20. What is ID? What is ID? Minus 2. Solvers. It's 1 over 5 plus 1 over 2 VOC equals 20 over 5 is 4. Minus 4 minus 2 is minus 6. Put it there, it will be 6. So if you solve it, V open circuit is 24 volts. Basically, this is 1 over 4.
second term is over 20.
Yeah, math is hard. Get it?
It's VAB is the same as V Thevenin.
Okay. If you're confused in the test, bring your voltmeter in the lab. You put them here, huh? Is this open circuit? V open circuit? Yeah. Is it the same voltage?
Yes.
Is it the same voltage?
No.
Why? Those are in parallel.
Okay.
Again, please, if you have 3 elements in parallel, open circuit in parallel with current source, in parallel with resistor, they are all in parallel, they have the same voltage.
Yes. Yes.
Explain it again.
Because so why we calculate V Thevenin and
Because it's part of your job to solve the spaghettis.
how can this help me to solve?
If you simplify it to, because if you connect any resistor or any element here, you know the current, you know the voltage easily by using V over R. If you connect a resistor load, you know it, then it's going to be V Thevenin over RT plus R load. That's the purpose of Thevenin. Or Norton is the same thing. You connect a parallel resistor to your system, you can know it. Now, all of you have iPhone charger, right? iPhone charger tells you it's 5 volts. This is the V Thevenin. Gives you 5 volts. But whatever inside is spaghetti. This is an application. You want to hear a story? I used to work for a small company for like an internship, and this company manufactures motors, okay? In the company, part of the job is they ask us to find open circuit voltage and measure R Thevenin because they have lots of car batteries connected in series or parallel, spaghetti. So you simplify it by having a simplified model. Once you have a simplified model, you can simulate it very easily, and the results will match. Get it now? So V Thevenin is looking this way, and he calculated V Thevenin and R Thevenin. How about Norton? Norton is another guy who is also smart, but he loves current sources, right? I have seen in my life Thevenin more than Norton because people naturally are more comfortable with voltage sources. Remember I told you current sources, you cannot manufacture them in real life? So that's one of the other reasons. So we find R Thevenin we want to convert complex circuit to its Norton equivalent method. There are 2 methods of finding I short circuit. So, to find Norton current, it's actually the short circuit current. Okay. So we need to short circuit the spaghetti circuit. When you connect a short circuit, you will naturally kill some resistors if they are in parallel. So, question in the test. What is RAB? This is 100 ohm.
0.
Why?
Because the current will not go through.
Because electrons are smart, right? Let's do it by math. 0 inverse plus 100 inverse, all inverse. What is 0 inverse? Infinity. Plus 100 inverse, all inverse.
0.
Get it? Get it? So if we short circuit, we can find I Norton, which is the I short circuit. Again, Norton is also smart. He would find R Thevenin, which is also R Norton. So R Norton, R Thevenin equal to R Norton, which is equal to RT. They're all the same. Just call it R Thevenin and move on. Okay? Get it?
Yes.
If I bring you this question in the test, will you be able to solve it? It's not gonna come, but me. Let's do an example. The same example. I'm not gonna do the same example. I'm gonna use another example. You want to do the same example? Let's do the same example. Again, R definite we already calculated, right? It was 33.
33.2 years.
50 parallel with 100. But how to calculate the I Norton? So, what did we say? Keep the original circuit. Again, when you do Thevenin resistance, do it in a separate circuit. And then go back to the original circuit and see, are you doing Norton or Thevenin? Get it? So the first step, you calculate R Thevenin, which is R Norton. R Thevenin, which is R Norton, which is RT. Do it in the corner of the problem, quickly. Once you're done, take it, put it on the side, and see, is the problem asking for Thevenin? You use the previous example, or Norton, you do this example. We are professional, right? So, again, we need to find I short circuit, which is I Norton. N for Norton. Yes, please.
This is for the second example. So there is no answer.
Oh yeah, you're right. Let's do this. Thank you for pointing out. Okay, we are professional. So let's connect this, the short circuit. We did the short circuit now. I want smart students to tell me what will happen. What will happen? No, this is an unusually looking circuit, right? Is the short circuit in parallel with the current source?
Yes.
Check. Is the short circuit in parallel with the 20 ohm resistor?
Yes.
So what did I tell you?
And cross it.
We can remove it, the 20 ohm. So actually no current will go here. So I 20 ohm equals 0. No current will go because electrons are very smart. They'll go to the short circuit. So can I erase it from my circuit?
Yes.
Yes.
Why?
Because I'm connecting a resistor in parallel with a short circuit, even though I put a current source here. All of them are in parallel. So I'm shortening this resistor. Basically, the voltage drop across this resistor is 0. If the voltage drop across this resistor is 0, because it's a short circuit, even the voltage drop across this resistor is 0. It means what? It means the current source will still be there, 2 amps will be flowing here, and the I short circuit is flowing here. So I short circuit is flowing where? Here. In other words, I have the 5 ohm here, I have the 20 volts here, so I have a current that goes here, right? Let's call this I1, okay? What is I1?
It's IS plus minus 2.
Okay.
It will be 8, right?
Well, what is the voltage drop here?
2.
What is the voltage drop here? What is the voltage drop here? 0. What is the voltage drop here? 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 Get it? So can I use the famous formula? I1 equals 20 minus 0 over 5. 0 volts here. Bonassar, what's the voltage drop here? Okay, what's the voltage drop here? 0. This is short circuit. What's the voltage drop here? What is the voltage drop here? So what's the current? It's 20 minus 0 over 5. So that's 4 amp. So I have 4 amp, 2 amp. What is I short circuit? I1 plus 2 amps equal 6. 2 plus 4 is 6. I short circuit is coming from top to bottom by definition. Did he solve it? He did not solve it. YouTube, where you can find the answer. Let me repeat this example because we have a miss. Before we repeat it, let me draw the Norton equivalent. So what's the Norton equivalent? It's R Thevenin. What's R Thevenin?
RT.
I already told you, 20 parallel with 5, 4. What is I Norton? Is I short circuit, right? Which is what? 6 amps. I2 is 0. You can do this method or you can watch YouTube and we'll do it again, one more time for you. What did we say about our Thevenin at the beginning? Kill the sources. How do we kill the sources? Remove that. Short circuit this. You will have 20 in parallel with 5. So our Thevenin is 4. R Norton is 4. Ohm, the same. Get it? You're done with that. Maybe if you have 5 answers, maybe R Thevenin equals 6, you will eliminate them. That's why I tell you do it, so that you can get higher grade. At least you limit your choices in the test. We will put it that way, to see if you find R Thevenin first or not. What's the second step to find Norton current? Short circuit your spaghetti. What is our spaghetti? It's the original circuit, صح? That's the original circuit. Current source, 20 voltage source, 20 volts. So you literally connect a short circuit here and try to calculate I short circuit. Again, by doing that, you're gonna know now is the voltage drop here is 0 because you're short circuiting. Is the short circuit gonna destroy the current source? No. What did I tell you? If you put a voltage source and a current source, it will die, صح? Ultimately. Same for the current source. Once it finishes supplies the current, it will die. If you connect a resistor in parallel with short circuit, it will be killed because 1 over infinity is 0. Get it? So I want you to use this trick, and that's why I told you we're gonna kill the 20 ohm. Do it in the lab. Put a short circuit and parallel the resistor and try to measure the resistance. It will be 0. What did we do is we did the simplest calculation, the node voltage ultimate formula, and we said I1 equals 20 minus 0 over 5, which is 4. KCL here. N equal out. What is N? I1 plus 2 equal out. I short circuit. So what is I1? It's 4. 4 plus 2, short circuit is 6. So that's the Norton current. If you want to do it with the simple examples here, once we short circuited this R2, we killed it. So I short circuit is going to go, is 15 minus 0 over R1. And that's how to do this example. R definite is the same. Don't waste your time. Start with R definite, which is R Norton. So how to solve these problems? Step number 1, find R definite, which is R Norton, which is RT. Step number 2, am I using Norton, Thevenin or Norton? If I'm using Thevenin, V open circuit. If I'm using Norton, I short circuit. Short circuit, open circuit. If you short circuit, you will kill usually resistors that are in parallel. Again, in step 2, you do not kill voltage source or current source. You kill voltage source and current source only in step 1 in the corner. Get it? Yes.
What will happen if we have 2 resistors in parallel and 1 resistor between?
2 resistors in parallel and a short circuit between?
No, and the resistor between the no, forget it.
Here? Okay, I need to know what is connected here.
This is not parallel.
This is neither.
So instead of doing a short circuit, just find the voltage at the R Thevenin and divide.
You can use source transformation later, and I'll go through it. But let me finish this example. What's R Thevenin here? 10 series with 4, 14. What is R Thevenin here? 10 series with, no. We kill R Thevenin, we short circuit this, right?
Yes.
So it will be 10 plus 4. R Thevenin here, we open circuit, we remove the current source. So this will be a hanging 5, right? So what's R Thevenin? 30. Okay? Now, how to find V Thevenin? The question asked about I Norton equivalent, right? For the first circuit, gonna solve it real quick. We already found R Thevenin, right? So keep the original. So you said I short circuit, right? We're trying to find Norton short circuit current. See what I'm gonna do. Again, we are professional, we need to assign currents. He didn't assign anything. So that's I1, I2, I3, plus minus, plus minus, plus minus. Get it? So I3 is actually I short circuit. So how to calculate I3? You can use nodal voltage, right? And then once you do nodal voltage, you can, that's one method. You can use mesh. I personally would use, which one do you want me to use?
Not.
Well, there's no Norton. Now, we're trying to solve this circuit.
Maybe mesh,
Our goal is to find this current.
mesh is better.
Mesh is fine. So IA, IB, right? Well, you can use current divider rule and do it quickly. Do you want to use current divider rule and do it quickly? Told you mesh. Let's do mesh. خلاص, let's do mesh exercise. So if you want to do mesh, this is 10 volts. This is 5, 10, 20. Who wants to be the KVL? Hamad Ibrahim. You start from here. Voltage rise, voltage drop. numbers. Plus 10. You can't see? Hamid Ibrahim. You can't see? تشوف? Okay. 10 volts. What's the voltage drop here? Minus, because it's a voltage drop, 5 times IA. That's I1 is IA. I2 is what? IA minus IB. What is I3? IB. Get it? So we do KVL 15 minus 5A. Rise or drop? Drop. 20 times IA minus IB equals 0. Let's do KVL here. Who wants to be the KVL? Abdul Majid. Rise or drop?
Rise.
What's the formula?
Plus
20
multiplied by IA minus IB.
Good. And then
The drop.
minus 10. The formula
IB.
equals 0. System standard form. Who wants to do the standard form? Standard form, what's the size? 2 by 2, 2 by 1. Coefficients of A,
Minus 5.
minus 25. Coefficient of IB, 20. Lower line,
Minus 10.
minus 20. No, it's plus 20.
No.
It is plus 20.
Yeah.
Who said minus 20? What are the coefficients of the B? Minus 30. System solvers. O equals?
Minus 10 0.
Minus 10, 0. System solvers.
0.85.
IB,
0.57.
0.57.
Yes.
Need confirmers.
Yes.
Yes.
So what is I short circuit? Is IB. So you want to replace the spaghetti with Norton equivalent. What is our Norton? Already told you. 10 plus 4.
14.
Why 40?
14.
14, you're right. What is I Norton? 0.57.
10 plus 5 or?
No, 0.57. The artifact, we did it before at the beginning. You short circuit this, صح?
Yes.
10 in series with the parallel combination between 5 and 20. Get it? What is our Thevenin here?
We can't.
10 plus 20. Because this is open circuit, the 5 will be hanging. It will be like that. What is our Thevenin? This and that in series. We don't care about this because it's hanging. And I'm not going to solve for I Norton here for the sake of time, but try to do it yourself. It's very easy. If you short circuit this, you use CDR, right? Yes, I know. What's your question?
لو بجيب الفولتج هذيك السيركت اضرب بس التيار مع
I need to solve it, so I would rather separate this problem because it's another problem. Let me solve this. What is, if you do short circuit, what will happen? This is the 20, the 10, the 20, the 5, and the 2 amps, right? So, what is I short circuit? You can use CDR, right? So I short circuit is CDR. So 2 amps will be split here and there, right? We already short circuit here, خلاص. That's a short circuit. We didn't kill any resistor because it's not in parallel with any resistor. So using CDR, it will be 20 over 20 plus 10 times 2, which is 4 over 3. So that's the Norton equivalent current. Use section 2.1, 2.2. You remember the current divider rule if you have two resistors? So those are in parallel. You agree with me now? Is it clear? So if you want to do for the second example, what is I Norton? 4/3. What is R Thevenin?
30.
30. Clear? YouTube. The slides is not complete for a reason. We want you to watch the lecture. Source transformation. Source transformation, if you notice that we will always have a relationship between V Thevenin and R Norton equivalent, right? Is there a transformation? إيش معنى transformation في الرياضيات؟ تحويل. Transformation, تحول. So we can transform from Thevenin to Norton using this. You replace the voltage source with the current source with the direction from top to bottom if it's minus and plus. Okay? And R Thevenin, it will be the parallel. And to calculate I Norton current is I short circuit. What is I short circuit? Is V over R. V Thevenin over R Thevenin. If you put short circuit here, what will happen if you put a short circuit here, ya shabab? If you put a short circuit here, I Norton is going to be V Thevenin minus 0 over R Thevenin. That's why it's IN is actually V Thevenin over R Thevenin. And that's the formula. I Thevenin is V Thevenin over R Thevenin. It's a simple transformation. So we did V Thevenin system, Norton system. We can now combine them and swap them. That's how to swap them. Voltage source in series with the resistance will be converted to a current source in parallel with the resistance. You must maintain the proper relationship, the direction of the current. So if you have, for example, a current source that's going this way, to replace it with Thevenin, it has to be a voltage source negative plus in series with the resistor. Get it? If you have an arrow from left to right in parallel with the resistor, you can replace it with minus plus and then a resistor. But this is stupid. Khalas, this is stupid. But you can do it that way. As a matter of fact, there might be some questions, but you have to do it that way. Okay? Basically, the negative and the positive should be direction from the arrow from top to bottom. راس السهم عند الموجب. واضح؟ راس السهم عند الموجب. Sometimes this is going to be very useful. And here we're going to do a quick example by looking. You can leave if you want. If you use source transformation, this will be this block. We can replace it with 10 times 1 volt, 10 volt source, and the 10 ohm it will be here. Then you can calculate I1. What is I1? You can use KVL, or you can use the node voltage formula. Remember the node voltage formula? V1 minus V2 over R.
Yes.
So I1 equals 20 minus 10 over 5 plus 10, which is 10 over 15, which is 0.67. You can do KVL. You can leave, but I'm going to finish this. You can also do a current transformation here. So 20 divided by 5 is 4, in parallel with 5. Then you do parallel combination, 5 and 10. And then the two currents, 1 and 4 is 5 times. So I2 is going to be current divider rule. I2 equals 5 over 5 over 5 plus 10. I2 is 5 over 5 plus 10 times 1 plus 4, which is 5. 4 plus 1. And then it's going to be 25 over 15 amps, which is the same as. No.
is by 3.
Well, 1 plus 4 is 5 times 5 over.
Is I3.
No, that's I2. Did I make a mistake? Oh, I2 is different than I1. So that's I2. 25 over 15. I2 is not same as I1. My bad. So what is I2? 25 over 15. What is I1? 0.67. So source transformation is a way to simplify the circuit. Next lecture, we will begin with a checkpoint, and then we will do maximum power transfer. You have any question?